Hello friends! Today we're going to discuss serotonin and hormones. We're going to discuss first how hormones affect serotonin, and then we're going to discuss how serotonin affects hormones. Now, I did do research on this for my book or for my series originally, and so I only referred back to my original research in this discussion. But I did research on it because I was doing an encyclopedic overview of serotonin's the biology of serotonin in the body. But I did recently receive in the last couple of weeks, and one of the reasons I made this series actually is that I received a number of questions from people about, because I mentioned SSRIs a lot, about how SSRIs may affect the body's synthesis of hormones. Now, I want to say something before I even get started. This is really just a question that is just, I don't know why people care so much about the hormones they synthesize. People, especially natural people who don't take steroids seem to think that, you can't imagine how often I get these stupid questions about, will this supplement increase my testosterone? Do you guys realize that increasing your testosterone from 300 on the US scale to 1,000 will barely influence anything in your life? You'll feel a little bit better, a little bit more energetic, but not much, and that's going from the lower end to the high end of the natural scale. So the synthesis of hormones is really, why are people so obsessed? I want higher testosterone. If you're so obsessed with that, then go inject testosterone yourself and get the real thing. Get a very high dose, 10 times what normal people can have. And then see how that affects, how you deal with it. What I'm trying to say is, the small fluctuations in testosterone or estrogen that happen with a natural person are not that, do not affect quality of life that much. And more importantly, testosterone, and especially testosterone, but in general hormones, are not that interesting. They don't influence productivity and outlook and lifestyle as much as people seem to think. Something that's way more effective, for example, are neurotransmitters like serotonin or dopamine or adrenaline. These are things that have huge effects. Now, estradiol and progesterone both have some very beneficial effects on health, and certainly testosterone does as well, but not something that people should be asking me that much about. And I barely get asked about it. I'm sure people like Greg Doucette, who have less useful things to say, probably get asked about testosterone constantly. It's really overblown. People should be asking about more important things. With that said, I'm going to discuss the subject exhaustively now, and I'm going to be looking down at my notes a lot because there's a lot of individual notes. The summary of all of this, just for you guys to know, is estradiol, or estrogen's effect on preserving brain function, which is very well known now to bodybuilders. I don't know if it's mostly thanks to me or thanks to some other people that were talking about it, but I thought I was the first one to talk about it. But estradiol's effect on brain function is mainly modulated, to our knowledge, by serotonin. So estradiol modulates serotonin, which in turn modulates the brain function, the neuroprotective. Estradiol has other effects, but a lot of it is through serotonin. In turn, serotonergic function in general, especially the increasing serotonergic function, appears to decrease steroidogenesis, which means the synthesis of steroids in the body, as well as to increase the ratio of estrogen to androgen, which means that either it decreases androgen synthesis or increases estrogen synthesis. And it also appears to have some effect on aromatase, but that effect is not completely clear. And there's also another effect, which is specifically that SSRIs affect sexual function. Okay, but we'll discuss that in a later video on SSRIs. And SSRIs change the nature of sperm. Okay, so this is an overview. Now let's get into detail. Number one, we know that estrogen modulates serotonin in the brain in a biphasic manner. We know that estrogen increases tryptophan hydroxylase 2 mRNA in the brain, which means estrogen levels increase the availability of the enzyme, the rate-limiting enzyme in the synthesis of serotonin in the brain. So more estrogen, more synthesis of serotonin. We know that overexpression of tryptophan hydroxylase 2 appears to mimic the effect in rodents of having higher estradiol levels, which means that the anxiolytic effect of estrogen in rodents can be mimicked by increasing the synthesis of serotonin, giving us further evidence that some of the behavioral impacts of estrogen appear to be due to serotonin. Also, knockout in mice, genetic knockout of tryptophan hydroxylase 2 reduces the anxiolytic effect of giving the rodents higher estrogen levels, which means, again, indicating that it's mediated by serotonin. In females generally, not mice, generally have higher blood levels of serotonin and higher cerebrospinal fluid levels of the of the serotonin metabolite 5-HIAA, which comes from monoamine oxidase's degradation of serotonin. Generally, women have higher serotonin levels. Let's put it that way. Female rodents have higher levels of tryptophan hydroxylase 2 and higher serotonergic activity in the brain. Tryptophan depletion studies show that the reduced performance in verbal memory and verbal fluency tests, which happens when you reduce tryptophan from the diet. See, this is very interesting, by the way. Many people interested in cognitive enhancement, particularly in memory and learning, are unaware that if you decrease tryptophan, verbal ability decreases. And this can be attenuated by estradiol supplementation, which is very interesting. Shows that serotonin has an impact on verbal fluency and verbal recall and verbal memory, and that this effect of serotonin, if you remove serotonin from the body and increase estrogen, you can mitigate this effect, which means that estrogen is making the serotonin in the brain more effective. I mean, I'm speculating here, but this is what it seems to be. So, also, there's some other evidence that estrogen's effect on working memory is mediated by serotonin. It also seems to be that estrogen protects against the development of schizophrenia via its modulation of serotonin, specifically the 5-HT1A receptor, which is desensitized by both estradiol and SSRIs. Why is it desensitized? 5-HT1A is an autoreceptor in the presynaptic cleft, and when serotonin transmission is made, we've talked about this before, but for those who haven't seen it, 5-HT1A recognizes the serotonin and reduces serotonin synthesis. So SSRIs decrease the sensitivity of the 5-HT1A autoreceptor, and so does estradiol, and it seems to modulate, estradiol's effect on schizophrenia seems to be mediated by its desensitization of the 5-HT1A receptor. I hope this is interesting for you guys. You see how this is really how estradiol is exerting its effect. Of course, estradiol is also an antioxidant molecule, and it easily passes the blood-brain barrier. So it also acts as an antioxidant in the brain. But most of its other effects are modulated by serotonin. So when you think estrogen is neuroprotective, you mainly think serotonin is neuroprotective, although there's an antioxidant effect, as I said. But many other things have an antioxidant effect that pass the blood-brain barrier easily. So, further, I want to say that in men, estradiol level is associated with 5-HT2A binding. There's an interesting study, I found this quite interesting, but I'll summarize it for you guys. There's an interesting study on rodents in which they made the rodents transsexuals. So there's female to male and male to female. In this case, the male to female rodents, when they switched from male to female, experienced reduced SERT binding. SERT, remember, is the serotonin transporter, which SSRIs inhibit. So when the males were given estradiol, the SERT activity reduced, which means there's more serotonin in the synaptic cleft. The female to males experienced greater serotonin binding. Testosterone also increased SERT expression on the cell surface, therefore reducing extracellular serotonin. Almost done with my notes on estrogen or on hormones' effects on serotonin. So in animals, the aromatase enzyme supports serotonin production. Estradiol and progesterone both interact with the promoter region of the transporter, SERT, with polymorphisms at that promoter region to mediate SSRI results. So essentially, the results of SSRIs on people are mediated by estrogen and progesterone and polymorphisms at that promoter region. I guess this is not very functional for people. Maybe I shouldn't have included it. Anyway, second last, I wanted you guys to know this. I'm aware of this, but I've mentioned this in videos before, but I don't know if that many other people are aware of it. Raloxifene and tamoxifen, which are selective estrogen receptor modulators, both reduce serotonergic activity in the brain. Because, see, these SERMs, they maintain some estrogen effects in the body or even increase them, for example, at the liver, but they decrease them in the brain. So they will not protect you, for example, from the neurotoxic effects of steroids. I mean, they will reduce the protection that you would have gotten from not using an aromatase inhibitor if you use SERMs. Finally, anabolic androgenic steroids in general lower blood levels of serotonin. They lower 5-HT1A and B and raise 5-HT2A. What does that mean? If 5-HT1A and B autoreceptors are lowered, that means there's less serotonin in the brain. And raising 5-HT2A means there is less serotonin in the brain. Because 5-HT2A raises so it can sense more. So basically, anabolic androgenic steroids decrease serotonergic activity in the body. I've covered AAS's effects on the brain in another video. Maybe I should link it here. To be honest, that video is not as detailed as I could make it. I was trying sort of to summarize the research. There isn't that much research on it, but I could make a more detailed video at some point, really. It seems people are very interested in that. But the main outcome of that research is basically serotonergic activity is decreased in the brain from AAS, and some of it is long-lasting. That's for sure. Now, let's talk about how serotonin affects hormones, since people are very interested in that. First of all, in rodents, the SSRI sertraline disrupts the endocrine system and reduces gene expression of some steroid genes. In humans, in vitro, which means in petri dishes, not in full human studies, 2 studies show that SSRIs may reduce steroidogenesis, which means the creation of steroid hormones or the synthesis of them, androgen synthesis, and, as I said, increase the androgen to or decrease the androgen to estrogen ratio. But it was noted that sertraline and fluvoxamine had the lowest effects on reducing steroidogenesis. I take fluvoxamine personally. One interesting thing here, though, is that prolactin release is mediated by 5-HT1C and 5-HT2 receptors. This is very interesting to me because it is well known that SSRIs increase sexual dysfunction in people, but it is actually not known through what mechanism this is done. And there are many papers that I've read on the subject, and nobody seems to know what's going on. My feeling is that it feels like, because it's quite interesting. It's not a reduction in performance ability. It's more of a lowering of interest in sex, which, to be honest, I find very. I experienced it a little bit, and I find it to be very functional. Like, I don't enjoy this idea of wasting your life thinking about sex and stuff like that. Which, thankfully, I never had that. Some men have a very big preoccupation with it, and some women do also, not to be sexist, but to me it seems like a very primal and primitive way to live, and so I appreciate the slight reduction that I experienced, but it's a reduction mentally in interest. It's not a reduction in ability to perform, and so in fact sometimes it can enhance ability to perform for some people. And so I don't see, to be honest with you, I don't entirely understand sexual interest in the brain, how it works in the brain. I've never really studied it that much. It's not a big interest of mine, but maybe I should study it because it's something that other people are very interested in. People may be very interested in how to enhance their sexual interest and mentally and so on. But what I'm thinking is that SSRIs are affecting at the very least, are affecting the production of steroids in the brain in a way that does not favor sexual appetite. Which is odd because SSRIs are known to increase, for example, and I'll talk a little bit more about this in a second, but they're known to increase the neurosteroid allopregnanolone. And allopregnanolone is known to influence sexual appetite. But as we see here, there is some link to prolactin also. So potentially there is something going on with prolactin. I don't know exactly. I may have to look into this at some later date. But to do that, I would have to really study how the brain is involved in sexual appetite in general, so that I could really understand the fundamentals. Because as I said, the leading researchers do not know how SSRIs affect sexual appetite. I bet though, if I study the thing comprehensively, I could find a protocol to attenuate some of the effects of SSRIs on sexual appetite. Although, as I said, personally, I don't really care about that. So, SSRIs are also known as selective brain steroidogenic stimulants, SBSS. What is that? That means at a lower dose than is necessary to inhibit the activity of SERT, SSRIs already... My God, I keep getting interrupted by this stopwatch I have that's running an alarm clock. I don't know why at this time, and I've just been interrupted so many times in this video trying to shut it off. So if it comes on, I just might leave it on. Anyway, the point is, at a lower dose than is necessary for SSRIs to inhibit the function of SERT, the serotonin transporter, they increase the synthesis of neurosteroids in the brain. So it's a pretty interesting outcome, and I'm sure that this continues at a higher dose of SSRIs, even the dose that's used pharmacologically to inhibit SERT, because we know that people who take SSRIs have higher levels of allopregnanolone. So, by the way, this is a great information for people that take finasteride, because finasteride lowers the synthesis of neuroactive steroids, particularly allopregnanolone also. By the way, not just SSRIs do this, but also mirtazapine does this, which is a selective norepinephrine and serotonin reuptake inhibitor. But by the way, don't take mirtazapine. It causes the most weight gain of all of these drugs. It's really intolerable. Anyway, but people are big fans of mirtazapine on YouTube. I don't know why. People always make comments on my videos like, have you tried mirtazapine? Have you guys tried mirtazapine? You'll gain 40 pounds. Seriously, it causes the most weight gain of all SSRIs and selective norepinephrine and serotonin reuptake inhibitors. Anyway, sorry, this is a bit off topic. So, one thing that your psychiatrist will never tell you, and I've never heard this from any psychiatrist, is that, and from many people, to be honest with you, most people don't know, SSRIs not only reduce sperm count slightly, change sperm morphology, which means this. By the way, there are three parameters of studying sperm: their count, their motility, which means how active moving they are, and their morphology, which means their shape. And there's also the DNA of sperm, which is rarely considered. SSRIs change all three of those, okay? A little bit to the worse, especially morphology. But many people don't know, and in fact, I've been told by one of the leading psychiatrists in the US that SSRIs do not affect the DNA of sperm. This is not true. This is not true. There are several studies that show that SSRIs change the DNA of sperm. Now, whether this really matters, I don't think so. SSRIs have been on the market for over 30 years. Many children have been born while the fathers have been on SSRIs, and we cannot discern any significant effects. Now, I haven't dug into the research to know exactly how is the DNA changed. And I'm not even sure that that's available in the research papers. But that would be interesting to look at, because I assume there's some kind of mutations and that these sperm don't end up succeeding in fertilizing an egg, which then would be fine. But I do believe very strongly that there are epigenetic epigenetic changes that occur to the sperm of a person that's on SSRIs. Why? Because the SSRIs change signaling so much in the body. They are one of the most effective medications in the world. If you take steroids, for example, anabolic, I just want to show you something very effective also. Anabolic androgenic steroids, they change your whole function of your brain, your body, everything. They put you on edge. They put you in a fight or flight response. They make you confident. They make you aggressive. They make you dominant. They do all of these kind of things. And they change your body composition. All of these things change your epigenetics. So if you have a child while you're on steroids, your child's epigenetics are going to be very different than if you were, for example, eating McDonald's and KFC and relaxed for a couple of years beforehand. The same thing will happen with SSRI. In my opinion, the epigenetics will probably be a positive change because you're not in an anxious state. We know that being in an anxious state when you have children influences the children's epigenetics in a negative way. So that's certainly one effect. I do want to mention, I'm talking mostly about men. if a woman is on an SSRI and gets pregnant, there will be actual problems with the baby. That's different, and they strongly recommend against taking SSRIs when you're pregnant. There goes my alarm again, but I'm about to finish, so I'm just gonna continue. I'm sorry, guys, I can't. This thing is crazy. I turned it off like 4 times. The final thing. Oh, I wanted to mention one thing about this too. Paroxetine appears to influence DNA damage of the sperm more than sertraline, fluoxetine, and escitalopram. The final thing I wanted to mention is that lithium also affects steroidogenesis just like SSRIs do. Lithium, as we know, has the most powerful impact on reducing the rates of suicide in people, and much of its function in the brain is determined by serotonin, and it too, because of serotonin, therefore impacts steroidogenesis. So that's all I wanted to tell you guys about hormones. You heard my introduction to this. I think that this obsession with hormones is a little ridiculous. I'll talk to you guys more about this in the last video in which I synopsized my view on serotonin and SSRIs. I gotta close this now because, oh, the alarm went off. Anyway, okay guys, I'll see you later.